All right. Well, we are at 7 o'clock, and we are recording. So welcome everybody to the Astro Cafe for Monday, the 16th of, not the 16th. What is it? What date is it?
Yeah.
It
Oh,
is the 16th.
it is the 16th. Oh my goodness, of March.
All based on
And
lunar authentic.
we are happy to have everybody here. Is there anybody, I don't think so. Is there anybody that is new to the group?
Okay. I'm sorry, but I still have a response.
I'm here
Is
now. Start.
Is there anybody that is new at the center?
No, we're all old.
You're all old. Okay. All right. All right. That's good. Well, thanks.
Various things impressed me.
Thanks everybody for coming. So I've just got a list here with Jeff and Chris Gainor, if he is available, and maybe, oh, there's Chris, David, Natasha, Randy, and then some announcements. Is there anybody else that has got anything that they'd like to add to the program tonight?
I sent a nice pretty picture of the sun because we actually see the sun.
A pretty picture of the sun. Okay, who was that?
That was Vince. I sent it to you.
Vince,
I sent
you sent it to me.
Yeah. Past present.
Let's see.
Okay.
I'm easy to train. You only have to tell me once.
I have a pretty picture from Vince.
No.
Oh, okay. Okay, thank you.
Very,
All
very
right.
rare case of me slumming of the sun.
We can get started maybe, and maybe Jeff, why don't you start us off, because you have just got, as you called it, like a little bit of a follow-up from the past couple of weeks that you've been chatting to us about the Artemis mission.
Yeah, thank you very much, Lauri. Let me just pull this up. So, can you see that okay?
Yes?
Somebody say yes. Okay.
No.
No, okay. Play from start. There we go. How's that? Yeah.
We are having
Give me a thumbs up, somebody, so I know that
we're having technical problems here.
okay. Do we need to-
So you have a screen?
That is a thumbs up.
Okay, thank you.
You're sharing your screen right now, Jeff?
I am. Yep.
Yes, he is.
Okay, we're only doing one screen, so I have to tell. Go ahead,
Okay.
and we'll figure it out.
This is actually a brief follow-up. We talked about rocket fuels of the manned space program last week, and at the end there was a casual but very interesting question because I had neglected. I just talked about the igniters being used and didn't really look into that at all. And a very with it question was, so what kind of igniters are used? And there were a couple of people speculating that, oh, maybe they just dumped hypergolic fuel in, and somebody else said, well, I wouldn't really like it to be like my barbecue lighter. But actually, both of those comments were really prescient. So I just looked into the various crafts that were used. And so if we start again with the display of the early space program, when we talk about the suborbital Mercury program, the Redstone rocket that used alcohol as its fuel, they just used a squib, a little explosive cartridge that was electrically ignited. So it just exploded and it fired off the alcohol. When we come to the Atlas rocket used with the Mercury program, that was burning kerosene. Indeed, they just used hypergolic starter. So they just dumped hydrazine in with an oxidizer. It exploded and set off the kerosene. The Gemini program, the Titan II, already used kerosene. Hypergolic fuel is a fuel that just ignites on contact. So the Titan II had already been using a hypergolic fuel, so there was no other igniter needed for that. And then you come, to the Saturn, that had several stages. The Saturn, the Apollo program. The Saturn V again just used a hypergolic fuel. to set off the rocket propellant. The second stage, the S2, which burned liquid hydrogen, used basically what they called an augmented spark igniter, and it was more like a spark plug. And it had about a 10-second burn, and all of the igniters are redundantly backed up. So if one fails, the second one kicks in immediately. When you come to the second stage, the S4B, it also used the spark plug type igniter. The LEM and the service module already used hypergolic fuel, so they really needed no other igniter. When you come to the space shuttle, interesting. So we get into the solid rocket boosters now, and the solid rocket boosters used an interesting process where they use basically an explosive, what they describe as a pyrotechnic device, at the top of the rocket booster, and then a what they call a booster ignition motor that blew the explosion right down the length of the solid rocket booster, so the entire solid fuel started burning at the same time. So it had a burn time, and that was when it was exhausted. The other main stage with the shuttle used basically a sparking device, an augmented spark igniter, and again redundant, but again like a spark plug. The orbital maneuvering system, which were those two rocket engines at the back of the space shuttle, just used hydrazine. So that was what they started with in space. Then you come to the Artemis program. Artemis program has the major core stage, which burns liquid hydrogen, and also the two solid rocket boosters. The rocket boosters use the same sort of process, so they have a pyrotechnic device that blows that explodes at the top, controlled explosion, I trust, and these are all electrically controlled. So controlled explosion, and then it's blown down the length of the solid rocket booster by what they identify as a booster ignition motor. Then with the second stage, which ignites in space, they use a spark device, basically a spark plug. And then the Orion craft itself uses hydrazine, so it's a hypergolic fuel. So that was my quick run through of the igniters that were used for the various fuels.
Jeff, do you know where the word hypergolic came from? Like I've never heard the word golic.
Very interesting question, Lauri, and I'd actually looked into that. And hypergolic is just the only thing I could identify about it was a word used by NASA to identify fuel that ignites on contact with the oxidizer. But I have no other word origin of that.
Okay.
Vince has a question.
I have a comment.
Go ahead.
There's a really good book. If you want to read into more of the various experiments and how they develop the fuel, it's called Ignition, and I can't remember the name of the author, but the title of the book is Ignition, and it's actually rather funny. It talks about some of the ways that they almost blew themselves up in the lab trying to develop these fuels, and how all these different fuels worked and all the different types of fuels that they tried.
It's interesting because as you go through them, they all seem to be controlled explosions, as they often refer to. I mean, these are just explosions waiting to happen, hopefully controlled. But that would be interesting to know the various types that they went through.
Yeah.
Yeah, go ahead.
What did you do? I don't know.
Oh, Jeff, we can now see your slides. Could you go
Oh,
over your
wonderful.
pitch again?
Oh, no.
Now that I'm not on anymore, that's awesome.
So we can't see.
Okay, Lauri, back to you.
Joe, will you have those slides up as part of the program that you put together at the end?
Well, it's part of the recording.
It is
Right.
visible.
It was visible to the audience
It
on
was
the
just in
internet.
the room that they were having trouble.
It's
But not
just here
to
in
the
the room
room.
that,
Okay.
that we're having trouble.
That's correct.
Okay. Okay. Well, you'll have to go back in and look.
Yeah.
There we go. Okay, thanks. Thanks, Jeff. And Jeff, you had a question for Chris Gainor online, and maybe we can you could talk about that a little bit, and maybe Chris could answer if he's willing to.
Sure, it was pretty casual. I noticed a news item. It was actually an announcement from the government that the space agency was pursuing some independent um, capability of the space agency to secure communication and identification from space with a purely Canadian space capability as one of the augmentations of the capability of the services. And I'd actually written Chris with the article and just asked if he knew about it and if he had any comments about it.
Chris, I'll hand it over to you.
Hopefully, Chris, you're mute, Chris.
Just give me a moment here. Just putting up a little illustration. Just a second. Where is it? Where did it go? There it is. Okay. So yes, today the Minister of National Defense is it just a minute. No, I can't see if you've got the slide up there. Do you have the slide up there?
Yes.
Okay, so the Minister of National Defense, is it Donald McGuinty? He's got a brother,
Yes.
Premier of Ontario for a long time. He announced that the Department of National Defense is going to be supporting the development of basically a Canadian launching site, which is already under development in the private sector in Nova Scotia. This has a bit of a tangled history because our first satellites were launched by American boosters, and then there was a major report that came in and from John Chapman, who's sort of seen as the father of the Canadian space program. And this report that he wrote in 1967, him and a committee actually directed the Canadian space program to communication satellites and actually away from a number of things, which it has since gone towards. I think it's kind of time to rethink how important that document was. I mean, it was important, but I'm not sure. We're kind of going in different directions, you know. So it kind of moved Canada away from scientific satellites for a while towards communication satellites, which have been very good for business, but no place in Canada to launch satellites. And it was suggesting that we don't get involved in human space flight, which actually happened in the early 80s after we joined the Canadarm program, and then we were invited to fly astronauts on the shuttle, etc. And hopefully soon Canadian will be going around the moon. But anyway, so every satellite, everything we've ever launched has always been launched somewhere else, mainly from the United States. But we have also called on launch services from elsewhere. Like for example, the MOST satellite, the Hubble Space Telescope, was actually launched on a Russian rocket. And we've also used French rockets and things like this. But today's announcement by Mr. McGinty kind of follows along with the government's latest announcements about defense. That we want to, we're spending more money. They want to spend more of that money in Canada, and also make us less dependent on other powers. The main other power not being named, but I don't think that's necessary to do. So today, this announcement was made. The place where this happened was at the David, Florida laboratory, which is on the edge of Ottawa, and this is a place where satellites are put through their tests and their various paces before they're launched. Interestingly, about a year ago, that place was in danger of being closed down. In kind of a budgetary exercise. That was narrowly averted, and of course now it seems to be more important. So the government is going to be investing more than $100 million, and this is over 10 years. In this with this firm, Maritime Launch Services. It's in the midst of building a set of launch pads, actually near Canso in Nova Scotia, which is where you go over from the mainland of Nova Scotia over to Cape Breton Island. Most of those pads will be used for private launch services, but at least one will now be dedicated to Canadian government launch services. I think in the short term, we're going to be continuing to use other launch providers, because it's going to take some time to get Maritime Launch Services up and running, to get their pads done and successfully launch rockets from there. Certain launch sites have different qualities. It's popular, for example, for communication satellites and things of that nature, where you want them in geosynchronous orbit. You want to launch them a lot closer to the equator than say Nova Scotia. So that's certainly a thing we can get from the Americans. But actually, the best site for that is owned by the European Space Agency, and it's near the equator in Guyana, in South America. So anyway, this is a departure. I think it's going to take some time to go forward. At the moment, they will be launching smaller satellites. I don't know when they'll be launching larger ones. And just another comment, over the years, there have been various concepts advanced by private business to launch satellites from various parts of Canada. I know at one time there was a proposal to launch satellites from the northern part of Vancouver Island, but that didn't go anywhere. So anyway, I think I will leave it there. Yes, Jeff.
Jeff, Jeff, go ahead.
Yeah, Chris, are they advanced enough that we know who's going to be developing the satellites or what kind of rockets they're considering using and who's developing those rockets?
Um, well, I haven't seen very much in this announcement. Canada, Canada has been for a long time. It has been known for a type of sounding rocket called black brants. And they're made actually in Winnipeg, and I think they're still making those now. As for larger ones, I've heard various people making proposals and things like that, but I'm not really all that up on how far along they are. But I'm sure it looks like in this announcement, in addition to this money I mentioned to go for the facilities at CADSO, I know they wanted to they will be putting some money into that part of the business. Of course, in terms of satellites themselves, there are a number of firms. I mean, the big Canadian firm is MDA, McDonald Detweiler and Associates, which is actually headquartered out in Richmond, and it kind of got its start here. At the time, another firm was our major satellite maker, Spar, but they've basically sold everything to MDA. But there are a number of other firms that are making the smaller satellites they're talking about right now. And MDA has not, there was a big move for Canada to make its own communication satellites. And actually, some of our annex satellites were made by SPAR and then MDA. And they've kind of stepped back from that a bit to making parts and systems for satellites. So again, this is going to be a bit of a challenge, and I know there are other firms popping up here and there. Um, our real sad thing is we had kind of a world-leading firm that was making systems for satellites called ComDev International, and it was swallowed up by an American firm a few years ago. So it's a dynamic thing. So we'll have to I'll have to, now that this is going ahead, I'm going to have to keep an eye more on the on that particular sector. We have actually already launched one satellite that by the DND, which is called Cassiopeia, and it was launched about 10 years ago, and it's still operating as far as I know. It's been looking for orbital debris, but it's also, I think, been enlisted in the search for asteroids and things like that. Now, having said that, our very first satellites were actually built by Department of National Defense scientists, the Alouette satellites. But then they all were kind of transferred into civilian agencies, and of course, since 1989, that's been the Canadian Space Agency, which will still be involved. Still going strong, but DND, I think, will be involved in, at least supporting the production by Canadian industry of satellites with a defense purpose. And I didn't see much in the way of particulars about what those satellites might be doing.
Thank you, Chris. That's great. Appreciate that.
Yes, I think I saw something just like a couple of days ago about Canada putting up communication satellites like in the same kind of Starlink way. And I was going, oh, more satellites. Oh, lovely. But I don't know how much. It seemed like they seemed to have said there were going to be quite a few. I mean, into the hundreds and stuff. And I'm going, okay. So I don't think we can get away from them.
Well, I imagine there's proposals out there on the table, and yeah, yeah. I mean, if it's decided that we need a system of that sort, I'm not sure whether people are all at it. At least in Canada, are that interested in depending on Elon Musk.
Right.
But I mean, there are other types of satellites. One of communication satellites. They don't necessarily have to be like those satellites. We seem to manage quite well with satellites in geosynchronous orbit. So, which is a whole different matter from what we're dealing with right now. So, I think that's a little speculative. Certainly wouldn't rule it out, but I think the Europeans are involved in something like that, and I think if they're doing something like that, there's a pretty good chance that we would work with them on that rather than putting up a system of our own.
Our own, right.
Because
Okay.
I don't think it could be just for Canada. I'm not sure whether the cost could be financially justified.
Yeah, the announcement I saw talked about it being integrated with other countries. So
Right.
in line with what you're saying.
A few months ago, the Canadian Space Agency announced they we have a cooperative agreement with the European Space Agency, which we've had for a long time, and it's actually kind of we aren't like a full member, but we're the next best thing. And a few months ago, we announced that we were going to be actually spending a lot more money with in ESA projects than we have in the past. The way the European Space Agency kind of works is they have all these projects, and the members can agree to take part in various projects, and they will agree to pay a certain amount of money. And let's say, a lot of them are scientific. I can't think of one right off the bat, but anyway, let's say we decide to pay 10% of the cost of a certain project, and the deal has always been that our industry will be hired to do 10% of the job. That's kind of the way it works in Europe. So I think it's a good deal for us, and it might be a good thing not to be so dependent on NASA, even though it has been very good. But
I came across an article this week about a company that wants to fly a constellation of mirrors up into geosynchronous orbit, and so that they can light up any place of the night side of the Earth for a charge. And I can almost imagine them reversing that. They'll just light the whole Earth up by default, and then they'll charge us by the minute if we want to actually look at the stars. That would definitely be the American way to do it. But
You should offer yourself to that company as a consultant.
yes.
well, that's right. Yeah, there was a thing a week or two ago about that. I think Nicole Mortellaro wrote something about it, and so yeah, I think it's several thousands of these things, and each one the light each one would generate would be similar to what you get from the moon. And of course, a lot of people have indicated that they don't like this. These proposals have come up from time to time for years. so far, all of them have failed or been shot down. Uh, but of course, in today's day and age, you can't tell what's going to go and what's not going to go. So,
I'd be
So-
tempted to shoot it down literally. But
that's right. I think that's a good idea. But the
Michael-
idea, one of the ideas they were putting forward is, well, we need them up there so solar power stations can operate around the clock, things like this.
So much for PST and PDT times, right? Yeah.
That's right. That's
Michael, you've
right.
had your hand up.
Just a footnote, Chris, I think it fits with what you just said, and that is that James Webb was launched by the ESA from Guyana.
Yeah, the ESA is a partner in Webb. Canada is too, by the way. And the ESA was a partner in Hubble. But yeah, part of ESA's contribution to Webb was to launch it. Because it was known that Webb wasn't, that the shuttle wasn't going to be available to launch Webb the way it had launched Hubble, and it was kind of a different thing. And the Ariane 5 was a suitable rocket to do the job, and it certainly did prove itself out.
Joe Carr just mentioned something in the chat about the Joe, what was it called again?
It's called Reflect Orbital.
Right. And
Yeah.
Sam Lawler is going to be one of our speakers at the General Assembly on May the 3rd. And so if you're interested in her fight with some of this, then please stay tuned. There'll be
Is
some
she the
more
one
on
from
that.
Saskatchewan?
Yes, she is. Yes.
Yeah, so yeah, I mean, this is going to become a bigger issue. I mean, we have the Starlink stuff. There's kind of growing evidence that when these satellites re-enter the atmosphere and they burn up, it's not all harmless. That
Right. Right.
that there is pollution there, and and the immediate reaction to these mirrors was what we would hear from the Pauls about, how this would really screw up, all sorts of living things on Earth beyond us.
Mhm.
Besides that,
Stay
if you
tuned-
really
stay
wanted to
tuned is what I would say.
7 years of bad luck.
That's right.
Okay, let's move on. We've got a little bit to go here tonight. David Lee, do you have something that's quick?
Yes, I do. So just bear with me. I'm just going to share. So this morning, I was sifting through my email and I came across the current copy of Sky and Tel. You can still get Sky and Tel digitally, and that's how I received it. And when I saw Compound Eyes, I thought, this kind of reminds me of something. And then I looked at the pictures down below that you can see here, and of course, we will all recognize Sandra. Let's see. Let's just minimize this. We'll already recognize Deborah Lockhurst of Dragonfly fame. Now, just as a reminder, Dragonfly started off in, I think, 2013 as an effort to image small diffuse galaxies, things that were probably just on the edge of detection, but because of the nature of light scattering and the current imaging at the time, it was really difficult to do. So Deborah and some people in Toronto, at the University of Toronto, were working on a project called Dragonfly. And the premise was by using commercial Canon telephoto lenses, which were at that time coming out with nano coating, which would really suppress light scattering. So they figured, well, yeah, I mean, these things aren't big, But if we ganged a bunch of these together, and it turned out in the original Dragonfly project, the telescope array, I think had 48 lenses. Now, I have a feeling it was split across two mounts. I think it was like 24 per. As I remember when I looked at some of the early pictures in 2013, the arrays only carried 24 at a time. So Deborah sort of carried on that work and kind of added in some stuff associated with using different wavelengths as well. So they built kind of a filter tilter that went on each of the lenses. So there was a lot of development, but I was surprised when I saw this, and I didn't realize this was happening. So this article is about distributed aperture telescopes. So there's more than one now, and Deborah is actually associated with the new manifestation of Dragonfly, which is called Mothra of all things. So Mothra is instead of being 48 lenses, it's going to be made up of, I think, 1,140 individual lenses over a number of mounts. I can't remember the exact number of mounts, but maybe 20, I think. No, I don't know. There's a number of mounts carrying like over 1,000 individual lenses. So Mothra, now and just see if we can find. So Deborah talks a little bit about Mothra. So she's involved in Mothra as well. So here you are. So she calls it getting stuck in the cosmic web. So they've always been wanting to sort of image these areas of gas, which were really difficult to do because they, as I said, they were just on the edge of detection. And with light scattering, they were never sure whether they were really looking at something. But with the use of this large array, they're hoping to see more, obviously. So I don't know if there's any questions about that. The full article is actually in Sky and Tel. I was actually quite surprised about the number of other initiatives. There was even one. Let me just see if we can find this one, which got my imagination going. This is 10 telescopes, but 10 tech 180 millimeter refractors ganged up together on a mount with ASI cameras on the back. And then
just one comment. About a week ago, Ivan Semenuk had a great big article in the Globe and Mail about Mothra.
Oh, cool. Oh, Gary has a question.
Go ahead,
Gary?
Gary.
Yeah, the big question I have is why don't you just use a big telescope to do this?
Well, I think the problem is it's very difficult to make. In fact, I think Deborah mentioned this in one of her talks. It's really difficult to make a refractor. Now they're really banking on refractors because refractors don't have any obstructions in the center, and they have superb imaging as long as you don't run into light scatter from diffusion and reflections. And they believe that they've tackled that. So anyways, by using smaller refractors, e.g. these telephoto lenses, those are easy to make. And even though they're not cheap, I think they're like $12,000 a piece. And I think, in fact, Canon had to introduce another assembly line just to make them for these types of telescopes. So they're building these kind of en masse now for the scientific community, but a lot easier to make that. Now, if you have an equivalent size refractor, you can't build it. It's just way too big. Brock?
Another factor that allowed it to do things big telescopes can't do, and that the filter was on the front surface where the wavefront's still flat.
Yeah.
And once you go through any sort of optic, you actually you basically you don't have a flat wavefront. And then the way that you can use the filter tilter to select wavelengths and filter basically collapses. You can't do it anymore.
Yeah,
and
so
I think that was a big part of it.
Yeah,
And
so
if you had
there's a picture of the
big
tilter.
aperture, you'd need a filter just as big, and you making dichroic filters in that scale, I think, is next to impossible.
Exactly. I mean, you think you have trouble with the amateur size stuff. Well, this is even bigger issue. You can see the tilter here. This is the filter tilter. It actually allows them to actually modify the wavelength. I know, am I right, Brock? I think they start off at a
Yeah.
certain wavelength in the interference filter, but by tilting it, they can actually get subtle differences in the wavelength.
Hmm. It's the
Yeah.
same reason why you get shift if you have a bandpass, like a really narrow filter that you're using for doing monochrome, if you're trying to get hydrogen alpha and you have a 3 nanometer filter, if you have a really fast telescope, you've got the angle that the light cone is hitting the filter varies depending on where it's hitting the filter, and that can totally change the way that the filter works. And that's why putting it at the front solves all of those problems. But it also adds a couple zeros to the price of your filters.
Yes, yes, and based on the number of lenses they have to use,
So Brock, so Brock,
that's a big bill.
Yeah.
so Brock, basically it's a filter problem is the issue, huh?
I believe that's one of the big
And
problems. Yeah.
scatter, light scatter is the
Okay.
main thing they were trying to solve.
Does light scatter on these big, huge telescopes, like Keck and all those things too?
And I think,
Yeah.
well, I think the other thing is that they're actually, by using slightly different tilts on each lens, they can pull out detail in some way. And I don't, it's probably some differencing thing where they're looking at just slight differences. It's been years since we saw that presentation. I don't remember.
Mhm.
Okay.
I'm
Okay.
getting
Thank you.
dragging it to
I really
depths of my
recommend
memory.
people going to Deborah's site, and it will you can see it actually here, lockhurst.github.io. If you go there, there's some relatively recent information of what she's been working on, and if you want certain details that neither I or Brock can answer, I'm sure she kind of
Great.
discusses them.
I thought it was going to be an obvious answer, but it's not. So
No, no, it's not an obvious. Chris.
More of a comment. I was just going to say, if you want to see the effect of one of these tilters, most solar telescopes use those to tilt the hydrogen alpha filter on the front. And so you can see if you're watching, if you can reach down and tilt the filter, you will see what happens to what you can see and what you can't see, because they are there because you do need to tune the filter to
Yeah,
see prominences, etc.
it definitely changes the contrast. Like for instance, the solar tilters. When and Chris is quite right. When you look at them, sometimes they look okay, but you tune it and it looks like amazing. Like the contrast is just extreme at that point.
That image that she has on the Mothra section there, that almost looks like it's liquid. It's pretty impressive.
I don't know. I'm sure there's a lot more to than meets the eye. I mean, yes, they're capturing over this numerous number of pieces of optic, but then I'm sure there's a back end in the workflow where they're doing a lot of processing as well. And that part I don't know anything about.
Well, thank you, David.
You're welcome.
More things to go down rabbit holes with. Yes,
Yes.
absolutely. Natasha, do you want to just give your
Yeah,
information
sure.
first?
Yeah, thanks, Lauri. I will just share my screen. Just take 1 second. Okay. So there I go again, starting a sentence with so. So we then first went up to Ladakh, and I was telling you about the Hanley Dark Sky Reserve in the Himalayas. And then we went down to Antarctica and explored the Halley Research Station. And now we're going to Greenland. So I hope everyone can see this image. And boy, this exercise really reminded me of how close Greenland is to Canada. And our hopes of joining the EU, I think, are pretty good. All right. So the Greenland telescope On a windswept stretch of northwestern Greenland, far above the Arctic Circle, a solitary radio dish scans the sky. Snow and ice stretch to the horizon, and winter darkness can last for months. Yet from this remote location, astronomers are studying some of the most extreme objects in the universe. So here is a map of Greenland, and you can see the current location in the northwestern corner. We'll have more on that in a minute. So it's a 12-meter radio antenna built to observe the universe at millimeter and sub-millimeter wavelengths. And interestingly, it was originally built as a prototype for the Atacama array in Chile. And then, so the telescope was later refurbished and adapted to survive in the Arctic. Then in 2016, it was transported to, it's pronounced the Pivnick space base, located roughly 1,200 kilometers above the Arctic Circle. So, as you all know, cold Arctic air holds very little water vapor, which can otherwise absorb or distort faint radio signals. And long winter nights allow extended observing sessions. So here's a picture of the Greenland telescope. And this young woman at the bottom here is a researcher doing several months of work up there. And it's a joint operation between, well, there's a few other entities, but primarily the Center for Astrophysics at the Harvard and Smithsonian, and the Academia Sinica Institute of Astronomy in Taiwan. So it's all part of the Event Horizon Telescope. And I'm sure I don't need to say anything more about that. You all know it's an array that links together 8 existing radio observatories across the planet to form a single Earth-sized virtual telescope. Named after the event horizon, the boundary of the black hole beyond which no light can escape. At least that was the theory until recently. So rather than a single instrument, the Event Horizon Telescope links radio observatories around the globe from Hawaii and North America to Europe, Chile, and Antarctica. So it's using very long baseline interferometry. The network synchronizes observations, effectively creating a virtual telescope the size of Earth. And it made history back in 2019 by producing the first ever image of a black hole at the center of the Messier 87. So these are all the organizations that are collaborating. So we mentioned already the Academia in Taiwan, who is actually the lead organization on the project. And then the Smithsonian, the National Radio Observatory, and the Haystack Observatory of the Massachusetts of MIT. So at the present time, it's located way up in the northwestern corner of Greenland, and it used to be called the Thule Air Base, but it was in 2020, the Thule Air Base was formally transferred to the United States Space Force. And then in April, 3 years ago, Thule was renamed the Pivnick Space Base, reflecting its status as a Space Force base and the native name for the region. And I meant to look up what that translates as, but it doesn't look like it would be pronounced Pivnick, but it is. Just going back to the origins there of the Thule Air Base, it was secretly built in 1951 as an early warning and strike base against the former USSR. But the base continues to serve its original mission of providing early missile warning and supporting space operations and acting as a forward base for scientific missions in the area. And I'm not sure if this is completely accurate, up-to-date information, but it's apparently home to 150 US Air Force personnel and 600 Danish contractors and government officials who maintain the base. So you can see where it's currently located up there, but it's going to be moved, and it doesn't say when. Just more on the location, filling a critical gap in the Northern Hemisphere, extending the distance between telescopes and improving the network's resolution. And of course, the clearer images allow astronomers to measure the thin ring of light around a black hole and to test Einstein's predictions under extreme gravity. So in the future, it's going to be moving over to the interior very high up, more than 3,000 meters. So that is the plan, to move it over there so it'll be more stable and ideal for millimeter wavelength astronomy. I couldn't find any information as to when they're actually going to move or why it's moving up there, apart from the fact that it'll be, much higher and drier and more stable. It could be that some of the melting of the ice around near the coast is having an impact. So this summit station in the interior high up was created in 1989, and it itself is a multidisciplinary research hub. So they're exploring meteorology, glaciology, atmospheric chemistry, and astrophysics are all involved there. And because of its high elevation, high altitude, low water vapor location, to measure components of the Earth system that would otherwise not be accessible. So here's an interesting view of Greenland taken from satellite. And as I was saying earlier, it's kind of interesting. There's another one here just to see how close I mean, I knew it was close to Canada, but I had no idea it was quite so close. And I don't know, Randy or any of the geologists in the room would know. It must have been part of the same body. It looks like it would have fitted in if it had just moved a bit further south.
You've discovered continental drift. Way to go.
Okay, so that's it. I will put in the chat. I see, Gary, you have a question, but I will put a link to a couple of videos that tell more about the technical side of the project. But Greenland is very much in the news these days, and that's what caught my eye. So I thought, well, let's go up there and see what's happening. Gary?
Thanks, Natasha. That was good. Something interesting about the antenna that you probably don't know. When I was working up there, the Atacama was, front and center because a lot of Canadians used to run it. But this is a metal with dish, and it has to be amazingly accurate. The surface has to be about 14 or 17 micrometers of accuracy. That's really, really accurate for a metal dish. I was quite amazed when I found that out. Also, I forgot what I was going to say.
Gary, I meant to include a slide about that because they were emphasizing the precision with which it has to be coordinated, and also with the other telescopes around the world. It's just an amazing feat.
Yeah. These are very, very expensive telescopes down in the Atacama Array. The other thing I was going to mention is I was sitting in with a bunch of scientists one day up there, and they were musing about what they'd like to do someday. And one of the things they really want to do is make a Canadian telescope up above the Antarctic Circle to have full observation, half the year of a lot of things in the night sky. They said there's a lot of benefits to that. I forget what they are, but this is something they're musing about. So we may see something like that someday.
You said Antarctic Circle? Did you mean to say Arctic Circle?
Arctic Circle.
Yeah. Okay. So the Greenland telescope is 1,200 kilometers north of the Arctic Circle.
I think there's
wonder about the logistics of moving something that large in that area, and then trying to get it back to what Gary is saying, such a high degree of accuracy in its parabola.
Yeah,
it's quite amazing. I can't imagine how they do it.
Yeah, there is a video on that. It was quite a feat But I thought it was neat that the Greenland telescope was actually an early model for Atacama for Chile.
Somebody in the room?
Yeah, I do, Vince. So you're talking about the accuracy of the parabola of the scope itself, but with interferometry, the baseline is incredibly important as well. In fact, I believe the longer the baseline, the more important the accuracy of placement is, because otherwise you become out of phase. And I'm trying to figure out, how do they manage that on a moving glacier? Does this thing like crawl?
Yeah, that's going to be an issue because it is moving, especially where it's moving to in the center of the of Greenland.
Yeah, like ice is never stable. It's always moving. Maybe not a lot up at the top, but I know from my mountaineering days, sometimes ice can move as much as 5 centimeters a day. We used to do a thing where we put a Coke can on the edge of a crevasse and come back at the end of the day, and it's fallen in because the ice had moved that far. So.
That doesn't look as though it's on ice though, does it?
Oh, no, where it is right now is on the
Or
rock.
where they're gonna move
But
it.
Natasha's saying they're going to the middle. I don't think there are any mountains in the middle of Greenland.
Well, it's a very high elevation. It's almost 10,000 feet where it'll be moving to.
But I think Vince is right. I don't think there's any bedrock there.
No, well, not for probably about 6,000 feet.
Precious metals.
Okay, so I'll find a link to a couple of those videos that talk more about the technical stuff, and yeah, so I'll stop sharing now. Thank you very much.
Being a radio guy, I've got my brain immediately went to, how the heck are they phasing this? So.
Thank you, Natasha. I always really enjoy when you bring us things that we don't always know about. Wade, yeah. Oh, Wade, you're just clapping. Thank you. Okay. Okay. Let's. Randy, are you ready to?
I am ready, and I'm going to start with Vince's photo, which will make a nice segue into my talk. So you're off.
I got desperate. Hadn't seen the sky for a while. And needed to take a picture of something because I was brought a wonderful diagonal from Sid's collection, and I've been dying to try it out. So I saw a wedge of sun, and I ran out there with my tripod and my small telescope and hooked it all up and took a picture. This is a very rare picture of Vince going after anything other than deep sky objects. So yeah, this is a rare picture, but I figured I'd share it. It's done in hydrogen alpha. I don't know what I'm doing. Roast me.
No, it's not bad. You can definitely see an aureole around this big spot.
Yeah.
And there's a cluster here, you really caught it.
It actually, at events, it almost looks like a transit.
It does, doesn't it? Yes.
Yeah. Well, did you shoot this through a diagonal?
I shot it through the diagonal. I know I should probably just go direct path, but I wanted to try the diagonal.
Oh, cool.
Yeah.
And what camera were you using?
I was using a ASI 385 MC. Just a little planetary / guide camera, and I was using the 62 millimeter scope I bought at the swap meet.
Oh, excellent!
And a very very janky solar filter.
Be careful.
That's one thing I gotta improve on.
Well, Vince wasn't looking through it; he was imaging with it. So.
I was exposing my camera to it. But yeah, it's definitely one of those be careful, do not look into eyepiece with remaining eye type setups. So
very good. So last week I talked about daylight saving time, and we were talking about solar time, and I figured it's time to do a talk about sundials. So here we are in Beacon Hill Park in the Rose Garden, and there's this lovely sundial in the middle. Let's go take a look at what we do with them. So it starts, of course, with time is based on where the sun is. We forget about this with all our watches and clocks and now our electronics, but the animals certainly don't know about that. And the farmers don't really care what the clock says. They don't care about daylight saving time or whatever. They want to know when there's going to be dew on the ground and when the cows want to be milked. So this is one of Dave's friend Luca's amazing photographs. He talks about how difficult it is to find a whole clear day around the winter solstice in Edmonton. And this one, in fact, was 2 days that he took this picture over. Just to check that you're thinking about what he went through to get this picture. Why is there one picture which is kind of blown out and the rest are looking okay? Not a trick question.
Getting short exposure to get the little ones, and then he had to do a longer exposure to get the scenery.
Yeah, he wanted one picture of the scenery.
Yeah.
So he did a reasonable exposure in the early afternoon, and the rest of the time, the sky was so dark that all you see is the dot, and then everything else would have been black. Anyway, as you can see, at some point in the day, the sun is at its highest, and we call that noon. And it will be pointing accurately south from where you are at that time, unless you're in the southern hemisphere, in which case the sun, again, rises in the east, sets in the west. That's always the case, but the sun will be to your north. Anyway, by knowing where the sun is, you can tell what time it is. And you don't want to look at the sun, but you don't mind looking at the shadow of things. So here we go. Here's the sun, and the Earth is spinning around pretty accurately the same speed. I say pretty accurately because what's called the moment of inertia does change with where there's ice and where the tectonic plates move, and there's some motions inside the Earth. But to a very high degree of accuracy, the Earth is spinning at a very, very constant speed of one rotation every 24 hours. Okay, actually, for sidereal time, 23 hours and 56 minutes. That's a detail I'm not going to get into right now. Okay, I have to say the British Sundial Society has some lovely graphics, so you can go to their website. But here we go. And being the British Sundial Society, they are very proud to say that we base time on the Greenwich meridian, so 0 degrees longitude. But if we put a nice barbershop pole called a gnomon, that's Greek for teller. We put a gnomon up along the pole of rotation of the Earth, then every 15 every hour the Earth moves 15 degrees. Why 15 degrees? Because 24 times 15 is 360 degrees. Very good. And the other way to put it is that every 4 minutes the sun moves 1 degree. That's a very handy thing to know when, let's say you're doing a barn door mount for your camera, you have to turn it 1 degree every 4 minutes. Okay, so here it is noon, and in 1 o'clock the Earth has gone around 15 degrees. At 2 o'clock the Earth has gone 30 degrees, and after 24 hours it's gone all the way around. Okay, so far this is great as long as we're using our sundial on the North Pole. But for some reason, people like living at different places, and you can still do exactly the same thing by setting your surface on which you're looking at the shadow. You can set it parallel to the equator. So here we have the equator, and you set a plate with markings every 15 degrees, and you set this pole vertical, and you'll be able to tell the time. Now, this lovely beefeater isn't actually standing tilted. The beefeater is standing vertical, and it's the sundial. Whoops, go back. The sundial, which is going to be tilted. Okay, how is it tilted? It's tilted such that this angle here is your latitude. So at the pole, it's 90 degrees from the surface of the Earth. At the equator, it would be a vertical plane, and the gnomon, it would be horizontal. Okay, I brought some show and tell here in the room. So Vince, there is my solar compass. Oh, no, it came here. Look at that. Okay, I'm going to pass this around, but this is a tool that I use for measuring where north is, especially when I'm dealing with very magnetic rocks, which screws up my magnetic compass. I can use the solar compass as long as I can see the sun. So pass that around, Ken. And what you do is you set that white surface there to your latitude. Okay, so here I would set it to 48.5 degrees. And then I know what time it is. When I go in the field, I actually set my clock to solar time. So instead of right now it being 8 after 8, I would add 1 hour for daylight saving time. So that's 9:08. And then I'd have to add another 22 minutes. So my clock would say, oh, no, it's the other way around. My clock, thank you. My clock, instead of saying that it's 8 after 8, it would say it's about 10 minutes to 7 in the morning. And it also is great when you have your watch set like that. It makes you feel like you're starting your day really early. All the other people are using civil time, and I have solar time on my watch, and I irritate them all when they ask me what time it is. And I say that it's an hour and 20 something minutes earlier. Okay, anyway, then I turn this dial until the shadow is at the right time. And then I know that the plane is parallel with the equator, and this surface here is parallel with the Earth's pole. It's doing exactly what we saw here. Okay, so I'm using it backwards. I don't know where north is, but I do know the time, and I look at the shadow of the gnomon, and when the time is right, then I know that this is pointing to the north. Cool, eh?
That gives you true north, not magnetic north.
Gives me true north.
So then you gotta subtract, no, you have to add on your.
No, I correct my magnetic compass. This is what I need.
Okay.
I'm always interested in true north. Okay, so there are different sorts of sundials. This, I find this quite handsome. This it's called a polar dial. So instead of looking at this, go back, this equatorial plane, you take a vertical plane and mark it up. That's called a polar dial. The most recognizable sundial is where the gnomon is set to your latitude and the plate is horizontal. Okay, and so this is like the one that we have in Beacon Hill. This is a very handsome sundial where it has a horizontal dial, a polar dial, and a vertical dial all at the same time, all set at 9 o'clock at this particular time. I think it's a very clever idea. So now I'm just going to go through a bunch of different ones. I was at the Musée des Arts et Métiers in Paris, in 2022. And it kind of delighted me because there were these museum quality pieces, this one from the mid 18th century. So you hang this and you set this little hole here for your date. And this is the one that I have. So there's the hole. And you see that little dot there? That is the that's how you read the time with this guy. So you just dangle it, and when the dot crosses this circle, then you can read off the time. Very clever. Here's another one. Again, I have my own version of this, so you can pass this around also. But this one is from early 18th century. So it's a pocket sundial. It's got a little compass in it. And you can read off the time on this dial here. This one is outside the Pantheon in Rome, and I really like it. But there's the gnomon there, and we have these different times, and the other way is the seasons. It's actually really confusing. I'm not going to spend much time on that one. This is on Westminster Abbey, would you believe? And it's on two different planes. So this one is a pretty normal vertical axis sundial. And this one, it doesn't work at this time because it's on the shady side of the tower, but this gnomon then does a straight line across the dial. I gotta say, this is one of my favorite pictures I've ever taken of a sundial because it's in Paris and it's at the Rue du Cherche Midi. So the looking for noon street. Anyway, the building has seen better days, but the sundial is in very good shape. And at the top, hard to read, but it says Omnia Sol Temperata, which means the sun heats everything, or the sun keeps everything warm or temperate. There you go. So extra detail is that the Earth is spinning at a very, very constant rate. But as well as the time it takes for the Earth to go through 360 degrees, during that time, the Earth moves one day forward around the sun. But the Earth doesn't move around the sun at a constant speed. When we're closer to the sun, which happens to be in the northern hemisphere winter, then the Earth is going faster. And so the day is a bit longer. And then in the summer solstice, the Earth is a bit further away, and then the Earth doesn't go around the sun so quickly, and the day is shorter. And there's a once a year term, and there's a twice a year term. And so what comes out of that is the very famous analemma. So this is another Luca Vanzella picture where he puts his camera and takes a picture every, I don't know, half hour or so. No. This is one picture. He goes back to exactly the same position and takes a picture of the sun, a couple of times a month. That guy is amazing, Dave. He's amazing.
He's got a really good spot to set that on that south side of North Saskatchewan River.
Yeah. Anyway, these are real pictures of the sun. You can see there's a bit of cloud some days, but he's taking this always at exactly the same time. I didn't say what time it was. It was 9:45 in the morning. I remember reading that. And sometimes it's higher in the sky. That's the summer. Sometimes it's lower. That's the winter. But the other thing that you see is it sometimes is a bit ahead, sometimes a bit behind. And when we talk about civil time, it's the average time around the year. And so that leads to what's called the equation of time. And they've known about the equation of time. The Babylonians knew about it perfectly. Like they understood this. So how does it work? First of all, so when I go in the field, I have to set my watch to solar time. So I listen to the Dominion time signal, or I use GPS or whatever, and that is civil time. And then I have to know my longitude. So here in the Pacific time zone, our reference longitude is 120 degrees west, and here we are at 123.3. So we are 3.3 degrees west of the reference longitude for our time zone. 3.3 times 4 is going to be 12, and then one more, 13 minutes. Okay, so we are 13 minutes west in time, west of our reference longitude. And then we need an extra hour for daylight saving time. So that's an hour and 13 minutes. And then there's this funny curve. You have to look. So here we are, Jan, Feb, March. We are right now about 9 minutes plus. Okay. So instead of being an hour 13, we're an hour and 22 minutes behind. And if you go to your handy dandy app, the one that I use is called SunCalc, 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 and you take a look at what they call the peak level. When is the sun at its highest? It says at 1322. So that means it's an hour and 22 minutes after noon. That's when the sun is at its highest point and in the south. Okay, so here's a little experiment that I did at home. I planted a 20 centimeter rod vertically in a horizontal plate, and I marked every 15 minutes. Here in May, here in June, and what you see is that the shadow was at its closest, and the shadow was pointing due north at 13 o'clock and change. Okay, somewhere around here. So the funny thing about my sundial is, first of all, it's a plain sundial. I use it backwards. I use my sundials backwards all the time, apparently. So in this case, I I mark up my sundial, but unfortunately the sun and the rain bleaches it each year. So I haven't been able to keep it except in photographs. But this is how the sun moves. And I didn't put the gnomon in the middle. I put it over here. I put it over here so that as it gets to later in the year, I can keep measuring the time. But this is just in my front garden, my backward sundial. And with that, I thank you.
Gary, you have a question.
Yes, indeedy. So, Randy, I have a question for you. I've always been puzzled by the analemma. If the Earth was going in a perfect circle around the sun, would that be a perfect figure eight?
No, it would be just a vertical line up and down. We would still have the latitudinal change, but the sun would never lag or lead because the Earth.
Okay, yes.
Earth does its sidereal day, the 360, and it would move a certain distance around the sun, but it would be the same amount because by Kepler's laws of planetary motion, if the sun is at the center of a circle, both of the area that you sweep at, the triangle that you sweep out, is going to be the same every single day.
Okay.
So it would not be a figure eight, it would just be a line going up and down and up and down.
Okay, great. Okay, thank you.
That's a really profound question. Thank you. So
CJ.
I see CJ and I see Les.
Yeah, I was wondering if you ever heard about a digital sundial. It's let me share. It's a sundial usually
yes!
printed,
Oh,
and
thank you, CJ. I was going to put that in. I was going to put that in the presentation, and I forgot about it.
okay,
I
then
want
good.
one. I
So
want one.
yeah, so when the hole aligns, it actually shines a little picture of the sun, and it increments the number when the sun passes. So that was just my contribution.
I was told that it's actually very tricky to 3D print something without bumps and filaments and things. So that's actually not it's not the sort of thing that you just say to somebody with a 3D printer, please do this.
Yeah, it's quite tricky. You can order them already printed, and there is I can't remember, but there's like bigger one as a sculpture in some cities, but I can't remember exactly where they are.
It's such a clever idea.
Yeah.
Okay, Les.
I noticed a couple of weeks ago in the Times Colonist, there was a picture of the sundial in Beacon Hill Park, and the caption credited the installation of this sundial to the Royal Astronomical Society of Canada.
Really?
Does anybody know about that? No.
I've been there so many times, but it's got a Robbie Burns quote on it or something.
Well, let's just take credit for it.
Well, I thought it was nice that they gave us credit for something that we probably had nothing to do with.
Or maybe we did. We've been here for over 100 years.
We need to know our own history.
Wow. You know
Okay, somebody's got to go down and do a little bit of some digging on that one.
Yeah.
I nominate Randy.
Second.
In his spare time.
Okay, I got it here. It says the sun clock located in East Garden or Sundial Garden in Beacon Hill Park is a unique, interesting landmark, blah, 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 known as the Meridian Sun Clock or the Orological Monument. It was originally built in 1947 by the Victoria branch of the Royal Astronomical Society of Canada and installed by the Round Table Club. It reads, "I count only the sunny hours." So I'll put the link in for this.
Yeah, so there might be something back in some historical document.
Surely amongst all of us aged folks, someone remembers 1947.
Somebody must have calibrated it.
Yeah, that's really neat.
Probably Sid.
Yeah.
No, he wasn't still in India.
He wasn't here. Yeah.
I
right.
wonder who the Round Table Club was.
I don't know.
I wonder if they had any nights.
Okay, round table. I heard round cable.
I think it had something to do with eating and drinking myself.
The round table.
Likely. The round table
So Moira posed a question to me just in passing a little bit today. And so Moira, do you want to just kind of talk a little bit about what you wrote, and that I had said to you, I think we need to ask Dave Robinson this question.
Okay, so today or yesterday, I just learned that Oak Bay was installing new streetlights that are non-dark sky compliant, and they are aware of Cattle Point. They do talk about that in their OCP, but they had a survey, and I guess 58% of 132 people didn't like the dark sky lights, so they are installing the non-compliant ones. And I did wonder if RASC had an opportunity to have any input or to speak to them or appear before council.
I will try to keep it short. I've been involved bits and pieces with this for a year and a half now. Originally, the council was going to have to put new streetlights into Uplands. And the reason they had to put new streetlights in was they have a sewer problem now. When the original subdivision was done, they had cross connections between storm and sanitary sewer. And so at heavy storm events, they would overflow the storm and it would wash sanitary into Cadborough Bay. So we had for decades problems with sewage contamination in Cadborough Bay. So they finally decided they were going to fix the cross connections, which meant they had to dig up all the sewers in Uplands. And of course, where do the sewers go? Right next to the streetlights. The streetlights that were in there originally, and you got to remember this, when this particular subdivision at Uplands was developed, it got some kind of historical declaration for when it was, and it was one of the first planned communities in the country. So it has some kind of historical designation. So when they first put in the streetlights in there, they used a cast iron base with a steel pole and a little cast iron finial on the top, and basically incandescent bulbs inside of about a 6-inch to 8-inch globe. And so they wanted to replace all of these because the globes were cracked and they had to change the lamps originally from incandescent to compact fluorescent, and they aren't working right. And so they had to replace them all anyway. So they had a public presentation. They gave them 4 different kinds of streetlights, and they did it in 2 sections, two public consultations. And the first consultation, they picked a sort of a traditional squarish one with a cap on top that you could order in a dark sky compliant fixture. Unfortunately, the next time they had more people attend one of these public consultations. And there were some people in there that were really concerned about this historical designation. So they punted all 4 and instead chose one that looks exactly like the ones they got now, except the poles are taller and the globes are bigger. And of course, nobody makes those in a dark sky compliant configuration. So there's enough clout from some of the members in Uplands that they convinced the city to override the community plan to put in non-dark sky compliant fixtures. And so there are 3 or 4 residents and myself that have been going back and forth and back and forth and back and forth with council for a long time. And they just weren't persuadable. So what they did is they took this manufacturer's fixture, which is a round globe one,
with an LED lamp in it. And they did some kind of modification to the inside of it to somewhat restrict the light that goes outside and goes up, but not much. So they've started to install these things at the north end of Uplands, and they're god awful. I'm sorry, there's no other way to put it. They're taller. They don't really restrict the light very much that goes on the house side, and they don't restrict much of the light that goes up. But they're adamant they would not change those.
And they can't even shield for the people that don't want it going into their bedroom.
And the other problem with these lights is it doesn't meet the way you calculate street light uniformity on the streets to avoid obstacles and to make obstacles more visible and to get no glare in the driver's eyes. They've done nothing with the light distribution for that. And now they've put in twice as many.
Sounds like we're gonna have to reactivate FART, Fanatical Astronomical Response Team, with garbage bags.
It's just, guys, it's been driving me nuts. As a matter of fact, you saw the article in the newspaper. That was two of the guys that I've been working with in the community who have been pestering the hell out of the city for 2 years with no results.
And this is not something at the CRD level. Each
No,
municipality
it's
is on
at
their
the
own.
municipality level.
Is the dark sky site, is that some sort of provincial or local, how is that designated?
No, the original was in the, Oak Bay has a community plan, an official community plan. The OCP has a requirement for nighttime street lighting to be dark sky compliant. But for Uplands, they've waived it. And now they've done another piece of development where they have reinstituted the dark sky.
I mean, that sounds like the perfect place to completely bleed them to death with a class action lawsuit from every astronomer in the city.
Yeah. Fortunately, the only problem that and the reason I spoke up and I had a lot of discussion with council and with the mayor at the time is because it's somewhat adjacent to the dark sky at Cattle Point. I don't think it's going to affect the sky brightness at Cattle Point. There's not enough, and they're not close. The ones they're putting in now are not close enough. But I think the next step that we might take is we did dark sky measurements last year at Cattle Point.
Okay.
And what I want to do is when they got all these ones that they're finished fooling around with put in, I want to do them again and see if it has affected.
What would be involved, David? Do we have well-placed stations to reoccupy?
I'd have to look at the map again, but there's no reason not to go. Well, have they started already, Dave? Because what we could do is do it.
If you go at the west end, the furthest north end of Uplands on Beach Drive, there's about 6 or 8 poles in there between the yacht club and the end of it.
Okay, so we could start doing it just with this as the baseline, let them finish, and then do it again.
Yeah, and I think you did some at Cattle Point anyway, right?
I did. But if you want, we could look at a map and define another area and just get a baseline now. And then when they're done, do another one.
That might not be a bad idea.
Yeah.
That would be really, really good, David.
Yeah. If we can, there's a couple of spots right smack in the center of Uplands that have parks. Basically where the old tram circles used to go around when they turned around in there. That's basically, you could probably set up a station in there and take some measurements in there. Yeah, I'd be interested in seeing that.
Yeah. Okay. Well, I'll have a look at the map.
Yeah.
Kirsten, you had your hand up.
So it hasn't been ignored. It didn't fly past.
Thanks.
I've been doing my best.
Good work.
I think for the most part, my question was answered. I mean, my concern was, would this lack of compliance on the part of Uplands with I guess as part of their own official community plan, would that in fact endanger the RASC designation of the dark sky designation on Cattle Point? And I'm reassured. I'm reassured to hear Dave say that probably not.
Yeah, depends on what they do at that end of Uplands. And
Yeah,
of course,
because it's already, I won't say borderline, but it's, yeah, it's already borderline, and it's just anything more, and it would just be heartbreaking. And I just don't know if Uplands realizes like how, how detrimental that could be to that very special area.
They've been told that, and they've been told about its effect on nocturnal animals, on insects, on sleep patterns, on light trespass into private property. They've told all that. They know all that. There's an overriding concern for some of the residents of Uplands. That's a very unique development. All big houses on big lots with big trees, and they're scared, pardon the word, shitless, that if they lose their historical designation, that'll mean that developers can go in there, break up those properties, and put multifamilies into Uplands. And that's what's driving all the resistance to complying with this historical designation. So that's the fear from some Uplands residents, that it's going to drive development that they don't want.
Thanks for all your work on this, Dave.
Thank you.
I'm surprised you read the thing, because that just came out today. The article just came out today in the Times.
But
actually, Kirsten mentioned it.
Yeah, we were talking, a few of the ladies were together yesterday, and we were talking about this very issue, and I forget actually where I came across the update, but yeah, I knew that
My feeling is some people that live in Uplands, that own property in Uplands, that are worried that they're going to see development take place that they don't want, and they're politically connected, very connected.
That shows that sometimes rational argument isn't the only thing you need to muster. If we have members in Oak Bay, it would be helpful to muster the members.
We don't, though.
But
maybe we should threaten them instead, and that might get their attention. Just say to them, okay, well, this no longer complies with the dark sky urban park criteria, so let's pull a sign out and we'll just forget about the whole thing.
Oh, they'll say that's okay.
We've already said that.
Good.
That may affect the designation of Canada's first urban star park.
Yeah, sometimes you have to be not subtle.
Yeah, I mean, that's the thing.
We told the mayor and the council that, but they just.
That's the thing with garbage bagging lights too. I fought with Cypress Bowl for about 5 years. We garbage bagged their lights almost every single night. We would have to actually run from security at times, and they finally worked with us after about 5 years of pulling garbage bags off of their street lights.
Yeah, there's a few other things that have gone on around with the light pollution side in the city. We tried to get some changes made to the lighting in and around the school that was developed on Fernwood, and the guy with the city light department absolutely refuses to do anything. He's afraid that the residents, if we change the lighting that's in there to make it more amenable to the observatory that's in Vic High, that the residents would complain, and he would be chastised for changing the lights. Had a few discussions with the guys in Saanich. They put a light out in front of my house that shines in my bedroom. You think I can get them to change it?
Oak Bay came down right away and put up a lampshade.
Yeah.
Or shield, I guess would be.
Yeah.
And outside my door, I asked the city to put in a shield, and it came up the next day.
Yeah. Yeah, I had no luck with the guys.
Mine mysteriously had technical problems for months until I had a shield with it.
Yeah, and they
don't know who kept
and
shooting it
Saanich
over
put
the
some
BB gun.
Saanich put some new lights in a couple of years ago on Royal Oak that are square-sided things, and they don't have enough uplight shielding, because if you're up on the upper part of that road and you're looking down on where the marsh is, you can see light coming up from those fixtures.
It sounds like we've still got a lot to do.
Oh yeah, we try the best. When it's
Yeah.
driven by politics, it's a tough road.
Oh, we need to get political.
Wade, you had your hand up.
Yeah, I was just going to mention it's unrelated to dark skies, but there was a link, and I'll put it into the chat, and it was based on automobile light intensities too. And if meeting all the new vehicles with bright lights and the different types, it's they've got a form you can fill out too, survey on how this affects you and what you think of it. It's pretty interesting.
That's a really tough one because the manufacturers that design the vehicles are all in the States, and they don't give a shit.
It's compounded by the fact that they brought in this low VOC road marking paint a few years ago, which is utterly useless. You can't see the road markings anymore.
In the rain, particularly.
You could see them, and now you can't see them, and people are naturally not only the new vehicles, but now they're upgrading. People are buying these upgraded LED bulbs just so they can not drive into the ditch.
My biggest concern with the new vehicles, and includes the one that we've got, is they all come with very high color temperatures.
Yep.
They're all blue, white, and that's terrible for people like me who have corneas that are not clear anymore and have floaters in your eye. That white light scatters far more, and it makes it way harder to see at night. And they don't think about that. They should all be those old orange headlights.
Yeah.
Oh, because it goes through the.
It doesn't scatter like the white light does.
That's right.
I'm sorry.
I had a friend of mine who actually, on the story of orange headlights, he actually intentionally put in orange headlights. He got a ticket for it.
What?
Yep. You have to have your headlights have to be within a certain color temperature now.
That's an American thing then.
Yeah.
It's certainly not Canadian.
No, he's in Calgary, but they gave him a ticket for it.
That's amazing.
Yeah.
When the council looked at our budget the other about 2 weeks ago now, we didn't have very much. Well, we had put aside a little bit of money for the for quality lighting, but we didn't use it, and so I'm wondering if there's something that we would like to put in there into the budget, because it has not been passed yet, that if we wanted to do some sort of a project that might take some work at that. I don't know whether or not anybody's interested. Maybe they could get a hold of Dave Robinson or David Lee, and kind of propose if there's anything that we need to put in the budget for this that might be an idea for this year. So
just one thought, Lauri. Because I know I've been asked to I guess lead the quality lighting project or table at
Yes.
International Astronomy Day. And one thing, and I don't know if it's a budget item per se or this year, but it might be worthwhile to have a little bit of money in that just for public, like for printing. Like one thing I'm thinking, because what I was planning on doing actually for that was maybe doing up, and mostly for myself at this point, but just doing up some up-to-date information about the impact of light pollution and some more, I guess maybe more up-to-date information. Like what we have right now is really great. But maybe just adding on and getting some stuff ready, maybe in a bit more of an updated format. And if I,
it could be tweaked a little bit, that's for sure.
Yeah. And then maybe down the road a bit, we might want to work with it in a bit, maybe get some graphics in there or some key messages or some recommended actions for the public, and then print it, just a thought. Yeah.
Okay, sure. We can put some printing costs in there for it. Okay. There's a few announcements. Just before we leave, I realize it's 9:15. Wow, that went fast. Uh, uh, just for your information, there are a few of us that are going to be going out supposedly on Friday night to the Highlands in order to no, don't laugh. Um, don't laugh. We hope that it will be all right. For the Highland Star Party, that was one of Sid's very favorite things that he did, and we've been asked to help again. So we've got a number of people who have said that they would come out and help with that. So we're looking forward to that. And if Friday night doesn't work, in the middle of the river, that we might do it Sunday evening instead. So if people are still willing to put their name forward to kind of do Sunday, that would be great. Or we might even kind of put it through to April sometime, if we can't do it at this point in time. So thank you everybody for doing that, for putting their name forward for that. We are absolutely looking for people to help with for Astronomy Day. Ben Spiller and Randy and David and myself have been kind of working at getting different leads for some of the different projects, and I'm seeing people around here on the screen that have kind of put their name forward for that. But we certainly would like people to help out. There's because we are on from 10 o'clock in the morning until 3 o'clock in the afternoon. If we can kind of divide up the time and have people kind of working just like 2.5-hour shifts rather than 5-hour shifts, that would be wonderful. So if everybody did a little bit, that would be great. That's going to be April the 25th. It's a Saturday. And then in the evening, we're up at the hill as well. So if it's a nice night, we'd love to have you back up to the hill. We also are looking at May the 2nd, is so that just a week, or like I guess the next week would be is going to be the annual General Assembly for the National RASC. And we are going to be extremely well represented with from the Victoria Center, being asked to do quite a few, in fact, at least four, maybe five presentations. So your community here in Victoria is going to be extremely well represented at the GA, and so please you'll be able to kind of do some registration very very soon. We are going to be having a guest speaker on the Saturday night. There will not be a whole series of things on the Saturday. There'll just be the guest speaker on Saturday night, and then the whole day, or not, well, the whole day of sessions on Sunday. But of course, for our place out here in the West, we will be starting at about 9 o'clock in the morning, but we'll be finished by 2:30 in the afternoon, because we need to be at 4.5-hour session, like 4.5 hours across Canada for the GA. So just if everybody, I'm sure everybody gets the bulletin, and so there'll be a registration form in there to sign up for the GA. Now, is there anybody else that have got any other announcements? Those were my three.
Well, actually, just to add on to the impending summer is coming. We have a lot of telescopes coming out of Sid's garage, and we would like to introduce you to them. I think this summer we're probably going to grab a few out and bring them out to the hill. And if you're interested in learning about these, well, I wouldn't say barely used, but some of them vintage kind of telescopes, which are still capable, come and talk to me. Let me know that you're interested, and we'll definitely bring one out.
Yeah, great. So does anybody have anything else that they'd like to bring forward?
Lauri, just very quickly, I put in the chat about the bright headlights and how awful they are. I got
Yes.
a pair of blue light glasses, very reasonably priced, in the gift shop at World Jubilee Hospital. And I wear them at night when I'm driving. It makes a huge difference. And they were $17.
Okay. I haven't seen those before.
I
That's
was
interesting.
looking for a link to give you, but I can't find one readily.
David Lee is the host next week. I don't know if you have any plans, but we always like extra talks. Think of
Yeah,
things that
definitely let me know.
think of things you think the community would be interested in. Especially since we're going to have such clear skies this week, there's going to be lots of photos.
Oh, yes.
Keep
All right.
infrared.
Well, thank you to Chris and Jeff and David and Natasha and Randy and Dave Robinson and Moira. Oh my goodness. This has been an excellent a very wide-ranging
And
session
Elaine for
today.
the coffee.
Yes.
Oh, and Elaine for the coffee. Oh, Elaine, I have a present for you.
She just left the room.
I have
She just went out the room
and
to get some of the
because
stuff
you
out.
didn't get to pick it up. So we'll have to make sure that we get somebody that can take it down to you. So thank you so much for your help all the time at Astro Cafe. And I'll make sure that I can get that gift to you. That would be great. Okay. All right. We'll say good.
Thank you.
Say good evening to everybody. Thanks for
Good
coming.
night. See you next week.
Bye-bye now.